In a small town in Brazil, Pedro woke up with fever and joint pain, so he went to a hospital. The doctor suspected he had Zika, an infection transmitted by mosquitoes, and ordered an IgG-IgM test, which was positive for Zika. However, a few days later, Pedro's clinical condition evolved to hemorrhagic fever, and he had to be hospitalized because he was infected with dengue. Luckily, Pedro survived, but in Brazil there are many Pedros that don't, due to incorrect diagnosis of these diseases. But how to solve this problem? In the Egyptian mythology, the god Osiris was killed by his brother, and his body was cut into pieces and then scattered across Egypt. Isis, Osiris' wife, had to assemble them in order to restore him to life. Inspired by this idea, we designed Amit, a chimera protein made of fragments from dengue virus called epitopes, selected in order to specifically diagnose dengue infections. What are epitopes? Epitopes are target regions recognized by antibodies like IgG and IgM. They work like a key, which will fit into only a specific lock, the antibody. However, some viruses can share similar keys that fit into the same lock. This results in an event called cross-reaction that difficults the diagnostics of viral diseases like dengue and Zika. And that's where Amit comes to action, a more complex key that mitigates cross-reaction, preventing the misdiagnosis. To design Amit, we used the bioengineering cycle to select the most promising and specific epitopes. At first, we selected a few reported dengue epitopes. We then analyzed them through different computational tools so that in each cycle, only the best epitopes were selected. Thanks to Amit, dengue diagnostics will be more specific and people like Pedro will be accurately diagnosed. What if Amit's specificity could be broadened for other diseases? It can, since the methodology can be applied to other pathogen proteins. As scientists, we must impact positively with our inventions in order to build a better world. And Amit is only the first of them.